brief is Bernoulli's principle. Does anyone know what Bernoulli's principle is? No. Okay, cool. So I'm going to write out a very short definition for you of Bernoulli's principle, and then I'm going to draw on the board because, as we all know, I am an amazing artist. So Bernoulli's principle states something to the effect of a fast moving fluid, gas, or liquid will have a lower pressure than a slower moving, or still, fluid. All else being equal, right? Temperature and all that stuff. All else being equal. So how does that matter in our lives? Well, one way we can apply that idea is for aircraft. I'm going to do my best to draw an amazing object here. You're going to tell me what it is. Can you tell what that is? I just said aircraft. It's a wing. That is, I mean, it's look, I'm not an artist. I know I draw beautifully, but believe it or not, I'm not an artist. That's as close as I can get to drawing the shape of a wing, okay? So I'm going to use green for airflow. If the wing is traveling, okay, if the aircraft is traveling that way, right? Going forward. Forward is that way. Follow? That means the air will be traveling in this direction, yes? In relation to the wing. Everybody follow still? Yeah. Okay. Check this out. The air is going to get to the back of the wing at the same time. Okay? The air that has to go over the wing, or the air that gets to go straight under the wing. There has to go over or under. It's going to get back here at the same time. But wait, which air has to travel a further distance, a greater distance? The one that has to go over the wing. So if it travels a greater distance but gets to the rear at the same time, which column of air, which flowing air is traveling at a faster speed? So this is going faster than this air. Bernoulli's principle says that faster moving fluid will have a lower pressure. If you increase the speed of a fluid, you decrease the pressure. That's the relationship. So what kind of pressure will we have over the wing? Higher or lower? You have higher speed over the wing, so you'd have lower pressure. So I'm going to put an L. And usually on the weather maps, they use blue. I'm looking for blue. I don't see blue. Oh, well. So we have lower pressure over the wing. And then on weather maps, they use red. I do have some red here, right? For high pressure. Okay. So if you have lower pressure over the wing and higher pressure under the wing, where do things like to go to? In general, they try to go into more pressure or into less pressure. You're literally going to have like a vacuum effect above the wing. There's more pressure, so it's pushing harder on this side than this side. Does that make sense? There's more pressure, so more force being exerted on the underside of the wing, less force being exerted on the top of the wing. Does that make sense? So you have a net force upward. What do we call that in aeronautics, in aviation? It's an L word. The wing provides levitation, leverage, no. The wing does what to the rest of the aircraft? It lifts it. It provides lift Now, I like the word levitation, but does an airplane levitate? Does it like hover? No. It needs forward momentum. It needs what we call forward airspeed. Enough forward airspeed to get that low pressure above and the high pressure below to get lift so it can fly. What about helicopters, though? Helicopters levitate, don't they, kind of? They hover? They hover. So if you don't have forward airspeed, how does a helicopter fly? What goes in a circle? The propellers. So on an airplane, if it's got a propeller to propel it, that's the word we use. But on a helicopter, we actually use rotor blade. Have you ever heard that before? A rotor blade spins around on the rotor head, which is attached to the transmission, which is attached to the engine, and it spins up, right? Okay. The rotor blades, if you look close, actually have kind of, sort of, this same shape, all right? And the forward airspeed is provided by the rotational travel of those rotor blades through the air. So you still get low pressure above the rotor blades and a high pressure beneath the rotor blades. That's how a helicopter can fly or can maintain lift. Has anybody ever seen a helicopter where the rotor blades are starting to bend up? Anybody ever seen that? So if, let's say they're carrying close to their capacity, or maybe even they've exceeded what they're supposed to carry, those rotor blades will start to bend up because they're providing so much lift, they're being pushed up by that high pressure, and they're getting close to their limit. At some point, rotor blades fail, right? During flight testing, pilots will disengage their engines, and that's called auto rotation. As they fall, so you're in a helicopter with the engine off, you're falling, and they use the rotation of the blades to restart the engines, okay, or engine, depending on if it's multi-engine. And basically it looks like they're hitting the brakes. Sometimes they'll get really close to the ground. The military pilots do this all the time. They'll get real close to the ground, they'll hit the brakes, and the rotor blades bend up, and they stop in midair and then go again. It's pretty cool. Or if they're overloaded, the blades really bend. So I got to see a couple of times a Chinook sling loading a Black Hawk helicopter. So you have a twin main rotor. You guys know the Chinooks, the big helicopters with two main rotors up top, and it was sling loading, which means it had like this really strong rope or whatever around the rotor head on the Black Hawk, and it was carrying the Black Hawk, which is really kind of neat. But that's a pretty heavy load. So anyway, again, faster moving fluid will have a lower pressure. So to demonstrate here in the room, we can do that. We can do that. Take a piece of paper. You don't have, if it's in your notebook, you don't have to take it out of your notebook. Okay, you don't have to. If you want to, but you should be able to just have the whole notebook this way and have just one sheet sticking out the other way from your notebook. And last period I had people blowing like at the paper, like they were going, it's not working. Like, no. Hold it up, blow over the top, okay? And it will lift the sheet of paper. Blow over the top. It's the same as the shape of the wing, isn't it? If you go like this, as the air goes over the top, it's faster than the regular, like, stagnant air around it. If you're getting lightheaded, take a break. Yeah, it's gonna create lift